So this is for the homework packet 1 and 2 for Unit 2 in the second quarter. I've made this a separate video because these are very specific skills, right? So if you're having trouble dividing fractions or if you're having trouble multiplying numbers, this is the video for you. First of all, in this page, let's notice that there is an example right up here, this little asterisk. This shows us how to do it, right? First of all, it says take these mixed numbers and convert them to plain old fractions. And then down here, switch colors here, it reminds us that when we are dividing something by 3/2, it is the same as multiplying by the reciprocal, 2/3, right? So we take this number and flip it over, because when we divide, really we're multiplying, right? That's the skill that we need to solve problems. So all division problems become multiplication. End of story. All right, and here it's suggesting that if you have an improper fraction, you need to change it back to a mixed number, and I am fine. I don't need it to be a mixed number. Fractions are fine. Even if they're improper, I'm fine with that. All right, let's go ahead and try one out here. Let's take a look at A. First thing to remember here is that I have two whole numbers, right? So one whole number, two whole numbers, and that they are both cut into fifths. So that right there means that I have 5/5 and 5/5. That means that I can multiply 2 times 5, and I will get the appropriate number, 10/5. But don't forget, I still have 3/5 added on, right? There's these 3 extra fifths that are sitting here. So there are 10/5 in two whole numbers, that's that. And there are 3/5 in that fraction, that's that. Altogether, that is a total of 13/5. Right? The shortcut way of doing that is you just multiply the denominator, halves, by the whole number. One whole number has 2 halves, and then add on the extras that you have here. So there are 2 halves in 1, plus 1/2 here in the fraction, for a total of 3 halves. And that's a division problem. All right, next up we want to change that to a multiplication problem. So this is going to stay 13/5. I am going to multiply it by the reciprocal of 3/2. I'm going to multiply that by 2 over 3. That's the reciprocal of 3/2. I am going to try and simplify this before I multiply it if there's any common factors on the top and the bottom, but in this case there's not. So 13 times 2 is 26, and 5 times 3 is 15. And you are done. All right, let's try another one. Let's just move down to D. The numbers get a little bit more complex here, so please use a multiplication chart if you need to. 3 times 7 is 21. There are 21 sevenths in 3 wholes. And I also have an extra 6 sevenths, so that's a total of 27 sevenths. In this whole number, if I cut it into thirds, I'd have 4 groups of thirds, or 12 thirds, plus these extra 2 thirds, make a total of 15 thirds. So step 1, change them to fractions. Step 2, I am going to multiply by the reciprocal of the dividend to get carried away here, of the divisor. I said that backwards. 27 sevenths multiplied by the reciprocal of the divisor. So I'm going to flip that second number over into 3/15. Again, 27 and 3 can only really be divided by 3. And 27 can be divided by 9. Nothing on the bottom can be divided by 3 or 9, so there's no common factors on the top or bottom. I am going to do a little side work if I have to here. 27 times 3, you might not know that, so grab your pencil and type, or write 27 times 3. 3 times 7 is 21. 2 times 3 is 6. 7 plus 2 more is 8. 6, 7, 8. So that's 81. And 7 times 15, right? You might need a little scratch paper here. So 15 times 7. 7 times 5 is 35. 7 times 1 is 7. Plus 3 is 10. That's 105. So there you go. All right, I realize that's getting to be a little bit messy, right? So maybe you do your scratch work somewhere else, right? Maybe you do your scratch work on a separate piece of paper. All right, let's go. Someone in class asked about E. I think maybe the numbers got a little bit big, so let's switch it up a little bit here. Let's take a look at E. If I took 10 and I cut those 10 whole things, let's imagine they're apples, 10 apples, into thirds, each of those apples would give me 3/3. So 10 times 3/3 is 30, plus 1, 31/3. I am going to change this, right? If I had 5 apples and I cut them into halves, 2 times 5 would be 10. I would get 10 halves out of those 5 apples. Plus this extra half I already have, 11 halves. And that's still a division problem. So now I need to keep, switch, change, or whatever thing you remembered. I'd like you to remember that we're going to do 31/3 times the reciprocal of the divisor, the reciprocal of this number here, which is 2. Should change colors here. Try to be consistent. This is going to become 2/11. And again, there is no common factor here on the top and the bottom. 31 is prime, 2 is prime, 3 is prime, 11 is prime. They can't be divided by anything. So let's just multiply. 31 times 2 is going to be 62. And 3 times 11 is 33. And you're done. Okay, so hopefully that's enough to get you going. Let's take a peek at the next page, which is multiplication. I know a lot of folks are having trouble with multiplication, so let's take a peek. The trick is just pretend those decimals aren't there for a second, right? I'm going to erase them for a second. We're going to pretend they're not there. And now we're just going to do 38 times 26. 38 times 26. So you've got to know 6 times 8. Look it up in your multiplication tables if you don't know. 6 times 8 is 48. Carry the 4 to the tens place. 48, 4 goes in the tens place. Then we're going to do 6 times 3. We have to multiply this number by every digit on the top. 6 times 3 is 24, plus 4 is 28. Right? Now I'm going to cut a clean house here. Oops, I uncovered my decimal. It's okay, we'll just ignore it. And now I'm going to multiply by the tens place. When you multiply by the tens place, your answer should start in the tens place. And to make sure we do that, we're going to put a 0 in the ones place. Sometimes I cross it out just to show that it's a placeholder, right? And now I need to multiply 2 times each digit in the top number. So 2 times 8 is 16. I carry the 1 to the tens place. 2 times 3 is 6, plus that 1 is 7, right? And then I am done multiplying. I really just want to step back for a second and say, what we just did here was 6 times the 3 and the 8. That's 6 times 38. What we did down here was 20. That's the wrong color, green. Was 20 times 38. Right? Remember how we started in the tens place? Right? That made it seem like we're not multiplying by 2 anymore. We're multiplying by 20. That's why we added that extra 0 there at the end. So now that that's all done, we want to add these things together because really we want to find 26. Right? Our goal was 26 times 38. So we have to add these together. Let's add these together. 8 plus 0 is 8. 6 plus 8 is 14. Carry the 1. 7 plus 2 is 9. Plus 1 is 10. So that gives us a total of 1,048. And now it is time for us to go back and look at our decimals. Now, the only thing that's different about this in 4th grade multiplication is that we have to count how many digits are behind the decimal. Okay, so 1 digit is behind the decimal, 2 digits are behind this decimal, right? So, sorry, I should be more clear. This number has 1 digit behind the decimal. This number has 1 digit behind the decimal. So when I multiply them together, I'm going to have 2 digits behind the decimal. Another way to think of that is a tenth, right? This was a tenth, and this was a tenth, and that equals a hundredth. Let's go back up and look, right? That's why we put this example up here. What we did is we ignored the decimal at first, and we just multiplied. Like if I wrote these decimals as fractions, and we tried to multiply them, all I did is I multiplied the 12 times the 25 first, right? We multiply those numbers first. And then at the end, we went back and said a tenth times a tenth is a hundredth. That's us moving the decimal, right? So first, just work with the numbers, then work with the decimals. Just like here, we work with the numerators, and then we work with the denominators. All right, let's do one more, and then we will call it good. So here we're going to ignore the decimals for a second, pretend they're not there. I'm going to start in the ones place. 0 times 6 is 0. 0 times 8 is 0. That was easy. Now I'm multiplying by the tens place. So I need to make sure that I start in the tens place, and I'm going to do that by putting something in the ones place to keep me out of it, right? To take up that space. Once I do that, I can just pretend that I'm multiplying by 5, right? Because I don't know if you know, like if I did something like 5 times 2, that would be 10. If it was 50 times 2, that would be 10 with an extra 0 on the end. That's the 0 that I'm putting there. That helps me know that I'm multiplying by 50, and now I can just pretend it's a 5. So 5 times 6 is 30. I'm going to carry the 3. 5 times 8 is 40, plus 3 is 43. Great, so what we just did, I did 0 times 86. That was 0. Now down here, I'm doing 50. 50 times 86. And that came out to be 4,300. I'm going to add them together, right, to get 50 times 86, and I get 4300. I'm going to put the decimal in the right spot. This is a tenth. This is a tenth. That's one decimal place. That's one decimal place. And together they make a hundredth. That's 2 decimal places. That's the beauty of the base 10 system, right? Our number system is so convenient that if I multiply a tenth times a tenth, I get a hundredth. And if I count the same number of decimal places, I get a hundredth. Okay? So the answer here is 43.00, or just 43. I hope that helps. Let's ask questions in class if it doesn't. See you later.